Hi, my name is Patricia. I work for a company called Querex. If you have seen our previous videos, you already know what we do. We create these tools for LLMs. And today we're going to go a bit deeper. Usually when we build these tools are for CEOs, for executive committee members, so basically L1, L2, or L3 level members. But now we're going to go a bit deeper into the audience, and we're going to try to replicate something that is very interesting, is to predict the magnitude of tornadoes. And we're going to follow along Julia Silge, which is a very, very well-known and data scientist and software engineer. She studied physics and astronomy, finishes his PhD in 2005, has worked in academia, and is a very, very well-known international speaker. So yeah, we're going to try to follow along with this, so you can also compare basically what we are doing, right? So I'm going to be very straightforward. I'm just going to say, hey, can you familiarize with? So basically, it's going to go and read the post, so it knows what we are trying to do and get some insights. So yeah, basically understood that, and yeah, it's there. Has a full knowledge. So now I'm going to say, by the way, I downloaded the data and it's in my database, so you can see here the rows and everything. It's all is there. So I'm just going to say, sorry, I'm just going to say to connect to my SQL and get a bit of the same that what Julia is doing, explore the data, and so on and so forth. So let's see what happened. I'm from Norway, so this is not a tornado country, and as you can imagine, for me, it's like very hard to understand this data. I'm not an expert on tornadoes, and I don't have any kind of understanding about it. But this is something that, thankfully, we can rely on our tool to give us some information. And look what happened. The distribution is heavily right skew. About 80% of the tornadoes are F0 or F1, so minor damage, while only 1% are category 4 or category 5 catastrophic. And this matches the dataset from Julia Silge blog post perfect. So now I'm going to say we are not going to use Python or R, only our MCP statistics, LightGBM, and SQL Server. And now I'm going to tell them exactly what Julia did, was basically create some CSV file for the tornado table using the same features, and then train a LightGBM regression model to predict magnitude. So at this moment, we are just flying in auto mode. We're not even thinking here a bit. If you ask me, we're just following along and just tell him to proceed. So let's see. Well, as you can see, I have nothing in my folder right now. There is no Python, no R, nothing. So hopefully it will happen soon. It's running the query against the server, as you can see here. And for those who are not familiar with, when we are using this kind of tools, we're going to be moving a lot of data. And that is not a problem, but sometimes you will receive this very often, this summarizing conversation history, which means that the very limited context window that this machine has, which is 200,000 tokens, it gets consumed. And then this little highlighted part, summarizing conversation history, is literally a book where the LLM summarize what we have been talking about. And it takes a little bit of time, and it basically just write down, hey, I've been talking with the user about this and that. I'm doing this. I did this, and I still need to do the following. So it follows along. Yeah. So again, it gets consumed because the data is quite long. Let me see how many the split that she has was. Let me see, how was it? Yeah, okay, let me, so let me see that. Yeah. The training, 50,000. Let me see how much we were. Yeah, one more row, which is the headings, likely. So now we have the tornado training data. And we're going to move along and get the tornado test data. So for those who are not familiar, we basically have this this algorithm called LightGBM. It's a gradient boosting algo, and basically what it will do is to iterate over a trained data set, and then based on the learnings and the model that basically output out of it, it will test against the trained unseen data. And that's the way that you know that the model is performing, because if you were to give them all the data, then you're predicting over Y. So it doesn't make any sense. So you need to have this large data set for testing to see if you are actually predicting or not. Yeah, so it's still data wrangling. For those who are familiar with this, it always happens that you need to data wrangle the data from a SQL server to a CS file, from a CS file to a SQL server, and so on and so forth. This is nothing new. It's the nature of the beast. So yeah, even if you have a very smart LLM with state-of-the-art MCPs, like the SQL Server MCP, is still you're going to have the same issue. So yeah. So now finally, it has the tornado test and dataset, and now it's going to get the tornado trained dataset correctly with the correct, how do you call it, structure. And again, we are in Europe, so we are using semicolon, and for this we need a comma. All right, so we are almost there. So now we have the boss CSV file and have the proper formatting with decimal points. And now it will train the LightGBM regression model. Yeah, so we're basically now running LightGBM. Now I'm getting the predictions. So now they have the complete results, and now it's going to summarize what the model did, basically completely out of the box and with no Python and no art. All right, so let's read together what just happened. And don't worry about the issue with the data. This is something that every data scientist knows, that there is a back and forth with the data, the commas, the this and that, and we need to extract from a database, from an Amazon container, I don't know. It's always the same with this, so yeah, forget about it. The only thing that I'm happy now is that the machine did it for myself, so I don't have to do anything. So let's read together. LightGBM tornado magnitude prediction complete. I have successfully replicated Julia Silge's tornado magnitude prediction using only MCP tools, SQL Server Statistics, and LightGBM, no Python or R. The model result, the metric our LightGBM 0. So basically we are the same, literally. So R squared, the same. Yeah, doesn't really matter. So we have our model achieve comparable performance to Julia Silge benchmark with just 1% difference in RMSE, root mean square error, and R square. So yeah, we have the data, which is, the one row is the title, by the way, but it's the same as Julia. And here's the pipeline. We got the data source from SQL Server. We encode in we did the same as Julia. Trainer split, so basically the same. I'm pretty sure that she did the same. Yeah, the same. And then we use LightGBM regression, and this is the iteration. So training time, and that's all, right? So now now that we have this baseline, we're gonna do something a bit. We're gonna actually push the needle a bit, and we're gonna say basically to use the MCP statistics to check if there are any outliers. So the MCP statistic is a complete with a complete set of tools with 200 tools. So you have 200 tools that are made available to the LLM, in this case Claude Opus 4.5, and it will begin to reason over the data. And this is a bit of the heavy lifting job that a data scientist will do. The first one is just to try to get a good data set with back and forth, as you probably can imagine. Let me see if I can actually show you data mining cycle image. So basically, this is a bit of the data. Let me see what happened here. If I were to click here, doesn't happen. So if I zoom in, So basically, the business understanding was we need to determine the tornado magnitude, create a model, and then we need to understand the data. We prepare the data, and now we are into still trying to make, we are here a bit in data preparation and data understanding. We did one model already, we evaluate the model, but now we're gonna continue and we're gonna go again to iterate and try to understand more out of the data set itself. So again, we are in point 2 and point 3 now, back from the first loop, and we're gonna try to understand the data now using our MCP statistics. So just to give you some sense of what we're trying to do, right? Like we have the challenge, we know who is Julia, we know the results, we know the data set is close to 70,000 tornado observations spanning from 1950 to 22, 72 years of data, the columns. We have, as you can see, we have the problem with the magnitude. This is a highly imbalanced data set, so we will treat it as regression, not classification, or else we will just fail. Here's a bit of the reason why. Close prediction are still rewarded. Predicting 2.3 for an actual 2 is good. And we present the ordering. And so the insight is that a prediction of 1.8 is for an actual 2 is useful. If we run a classification system, we'll call it wrong because it's not the same. What you're seeing in action here is our model and stack. We have the MCP server, model context protocol, created by Anthropic. Our company specializes in that. Here's a bit of the architecture and the back and forth between the agent and the MCP tool that you have witnessed. And so you see it working right there. We're using Claude Opus for the agent, using SQL Server that you can download for free. We're using, in my humble computer, just a developer edition. The MCP statistic is the one that is now running the show here. And we're soon gonna read what is finally finding. You can start reading. I need to check something on my phone, sorry. And now we have a very, very deep understanding and very well presented. We are not even using Python R. So let's see what it says. The distribution analysis, the tornado length versus width. So it found something. The standard deviation, the median, okay, perfect, the max. Right. Okay, so it found some outliers. There's substantial outliers in both variables. Wow, the extreme. Using the so we have the width. The data is that skewed? Yeah, both are heavily skewed, right skewed. Okay, perfect. Okay, key insight for modeling. Log transformation will normalize the distribution, but tree-based modeling. Okay. Also now mall. Okay. So it finally. So I'm gonna just. It found there's a strong feature importance here. So I'm just gonna. I'm just going to ask for a little bit of a test between those characteristics, and I'm just gonna say this. So hopefully there will be a. a strong correlation. So we will see now. We need to check this one. And MCP LightGBM. LightGBM is something created by Microsoft in 2017, and this is what we are using as the backend. So let's see what is happening. Let me also, yeah. Okay. So basically we so this basically interact. We should create area equals length times width. So now the machine basically will do it for me. It found something, so I'm just telling you, hey, you know, since this is interacting, maybe we can create a new feature. And this is something that is called feature engineering. And hopefully we're going to use it. But also I'm gonna now that we understand that it's skew, that there are some domain features, and domain features mean that, let's say that you are the manager of a supermarket. You have domain knowledge. You know what people buy when they're when they come out of work. There will be a spike in demand. You know something that not a normal person will know. The same goes with tornadoes. I live in Norway. I have absolutely no domain knowledge of tornado. So what I'm trying to do now, once this is done, I'm gonna say that, hey, you know, I need to go and do some web search and find some information. So if you remember, like in the cycle of data mining or data science, you have this cycle, right? And we are still on this cycle. We're still understanding the data and preparing the data. But in a conversation, when we're having a conversation with a machine, and this is very different when you are a person that knows this very well, and you just do it with tools that require knowledge like Python, R, and we're gonna try to like we are doing here, like using MCP tools that works on our behalf, and we can have just a conversation going on. So let me see. Okay, so I have this. So yeah, so hopefully the machine will now begin to do the bidding for us. It's trying to get some information here. Let's see. Let's see what happens. Yeah, so I still creating the files. So now we see that we have a little bit more. So now we're gonna rerun the LightGBM just with that. And now it found an insight. I don't know if you read what it said, and a bit of the. I should have been more nicely and tell them about it. But now it's gonna find by itself something, a deep insight. This is like a wow moment, because it actually reasoned over, and it will see we will see what happened now. Now this is fun to see to see how this is working. All right, so it didn't work. So let's see if we can actually tell them to use the log transformation that we were seeing. So now we're gonna go full mode. So now we went one more step, and now that the model said that it found that the log transformation stuff that we can use, now we're gonna use a log transform for the skew feature like length, width, and so on, and we're gonna still have the interaction with length width and width length ratio. We're gonna cyclical encoding for month. We're gonna use domain feature like East Tornado Season, the total casualties. We're gonna add Latitude as a feature, and now we're gonna ask them to export this data as a train and test with a split between 80 and 20. All right, so let's see. What it's doing right now. Let me see. So now we have this new dataset called Train Advance. Where is it? Let me see. Train Advance dataset right there. So now I'm gonna create the test file. And now we have both. So, and now I'm going to, one of the things that are very quite funny about the working with LLMs and this is that you can actually bring some kind of character. And the kind of character I'm going to use is basically, I'm going to say, now I'm going to train the model and see what happens. So now it's getting better. You see now I'm beginning to learn and understand. Too many trees. I said, well, okay, let me. But I'm missing some features here. Let me see if it's, let me just, I want to say, can you go to, can you use, did you add is summer? Let me see, is summer, summer is tornado season features. Also, since I am not a tornado expert, can you please use web search and get information and get domain information? So this is what I was saying. Like, I live in Norway, so there are no tornadoes here. So we're gonna go to the web search and let the machine do the bidding for us. And so far we've been using, let me see, 30 minutes. No, let's put 25 because there was a bit of explanation at the beginning. But in total, we have been using 25 minutes. So hopefully, let me see how long is the one from Julie?
Hi.
This is 37 minutes. So hopefully we get something something better in 37 minutes. So let's see if we can beat this. We can beat the model. Well, right now we see that we are a bit better, but Julia did this really like not in competition mode, if you will, and it was 3 years ago. So yeah, we should be at least getting a 0.8 RMSE score and a R square of 80, I will say 84 or something. But let's see what happened. Okay, so now we went and we got some domain knowledge summary. Feature is peak month, perfect. If May, okay, is okay. So now we are getting look, is tornado early? Is Dixie early? This is something that I didn't know. So you have increasing intensity. Okay, perfect. All right, so let's see what happened. Very nice. This is very, very nice. You see, this is why it's so important that when you're running something, you familiarize with the information. I could have cut the time of this video probably by half if I were just to tell the machine immediately go to web search and do what we want to do, right? So let's see. So let's see what happened. Yeah, perfect. Perfect. So now we'll see what happened. And I have one more trick out of my sleeve if this doesn't work. So let's see what is going on. So now it's training. All right, so this is now better than in Julia Silge's boost. Let me see. I'm gonna start tuning this. So LightGBM has a registry of all the models, so it can basically read back and say, oh. So let's see, Julia did 0.57, and we are doing that, right? Okay, so now it's time to bring the guns out of the out of it. So let me give me 1 second. So I'm gonna go full. And probably my machine will. So now I'm saying go full ELON mode. Iterate as hard as possible. So one of the things that you can say to a machine is to put a character. So I think that the machine will understand that what I'm trying to say, like, go insane, like explode the LightGBM model and try to find something that is better. This is gonna be funny. Now we're gonna see how smart is the machine. Okay, we're on fire right now. We are 10 points higher than Julia. Okay, now we are at 71. And the error, and getting lower and lower. Okay, let's see. This is gonna get insane at one point. But remember, this is this is training. So maybe it's gonna start overfitting. But what do you remember? That we have an unseen dataset with 15,000 observations. So the machine can now do whatever it wants on this training dataset. But with 15,000 observations that it will train on, that will basically prove. Okay, now this thing is beginning to be insane now. We are in uncharted territory now. This is getting insane, to be honest. I'm gonna make it bigger so you can see it. Yeah, absolutely insane. But remember, whatever the machine says at this point doesn't really matter. What it matters is only one and only one thing: what will be predicted on the unseen dataset. So we have 15,000 rows, and we'll see what happens. Jesus Christ, man! Wow. Just to put in context, what was the what is the result? Okay, where is the result? Okay, now this. Let me see. I'm sorry, I'm just laughing at this point. Like, this is gonna get insane right now. We are 30 points, 30 points higher in our. No, I lost track of the result of. Wow, this is okay. This is just. Now I'm at this point. I don't even care if you tell me that you're gonna reach 99.9% now. R2. Now I don't care. I just waiting for this madness to finish and prove that is wow. And I just want to see how insane it goes. But then, okay, talk is talk. Do it against the unseen dataset, which is 15,000. It's a massive dataset, so yeah. So most likely I'm not the. Wow. Jesus Christ, man. And it's running 1, 2, 3, 4 of this. Let me see how is my GPU doing. I mean, sorry, my GPU, my humble computer doing. No, actually, I'm not even gonna touch it. We're probably gonna black out. Wow. Jesus Christ. I need to put a music. I need to put some music on the back end. So let me just try to find my Spotify. Wow. Are we really going to go to 90%? But anyway, I'm not gonna put any music, otherwise I'm gonna get my video strike out of YouTube. So I don't want to do that. Okay, now, so as a test again, and now try against test dataset. So now talk is talk, but now let's see what happened. So this is the moment of truth. Like if okay. Okay. So remember when I said like the machine can do whatever, it can tell me in the training data set, okay, I'm getting 90, 95, 99, but you have the test set. So that in the validation set, you have some basically kind of overfitting, but this is the test set with 15,000 observation is the one that it did not see. So obviously we want to expect a drop, and the test result shows the expected generalization gap. So the R2 dropped from 0.9 to 0.83, which is excellent. The RMSE increased from there. So this is completely normal. The validation metrics were on in sample. Test R is still outstanding for tornado magnitude prediction. So the final benchmark. We have Silge, our original baseline, which was a bit worse than Julia. And then we have the insane mode. So what are the key achievements? We beat Julia benchmark by close to 40%. We have the R2, which explains the 84% of the magnitude variance, and so on and so forth. So to summarize this, if you give me 1 second, so I can update some stuff here on the back end. Let me just update with the magic of what is it called? Just 1 second, so I can just. If I make a mistake, doesn't really matter, but and let me see. Let me ask the settings of the winning model were using Dart or something else. So let's see. So let's see what is yeah. Yeah. Okay, let me see what are the best features. What were the best features? The boosting was GBDT. Okay, sorry. There was when we try to use this. Okay, switching. Okay. All right. So now we have the. Can you give me the? Can you give me the features that added more value? Yeah, exactly like where we discussed earlier, right? There was a strong indication that width length ratio area dominated. Latitude was the #1 predictor. The engineered features paid off. Width length ratio, remember that the machine said, oh, maybe I need to use the log because it's highly skewed. The cyclic and encoded worked. Perfect. And domain flags underperform, actually. The binary indicators, tornado alley, peak season, etc., added value, but less than expected. The model learned these patterns implicit from latitude, encoded, and month features. All right, so we were able to beat a bit of the model that we have here with Julia. It's not it was never the idea, but now you can see that we have this opportunity now where you can talk to a machine, where you can have a conversation, a natural conversation, and this machine has access to this very complex, how do you call it? How do you call this? Basically tools that will help you to interact without the need of using any other software like R or Python. And if you were not having this information in a SQL Server, you probably will have done everything with just a CSV file, and you will have saved yourself the time that you saw going back and forth with the SQL data stored in our SQL. But it was meant for you to show you that this machine also can speak to a SQL machine and so on. So yeah, this was the presentation, and I hope you enjoy it. I'm pretty sure that if I push the machine now further, I will get even a better result. I'm going to now ask, can you write a Quarto document with the insights, the parameters of the best model, insights, learnings, and so on. So this I will publish in our webpage, and you can read it. I think it will be very, very interesting. And as usual, I will share the data set that we use, the link to the post, the original post from Julia. She did all of this in 37 and 38 minutes, and we use 53 minutes. So yeah, maybe 43 if we discount the introduction to basically what we do and the tools that we are using. But I think it's we can do it a bit faster than next time. So with that, thank you, and I'll see you soon. Thank you very much.